you who missed the earlier sessions, my name is Ira Singh and I lead developer engagement at Microsoft India. On behalf of Microsoft and NASSCOM Future Skills, I welcome you all to the AI Classroom series. This is the second module in the series. The 2.5-hour session will open with a brief core note by a leading expert in the field of data science and AI. This will be followed by 2 hours of course content. In the end, we have about 30 minutes for you to ask questions from subject matter experts. You can also ask questions during the session or using the chat window option. There are a total of 3 modules in the series. Please ensure that you attend all modules as each of them covers an important topic on artificial intelligence and the powerful intersection of data and AI tools. And yes, do not forget to claim your swag and additional reference material from the resources section. I do hope you find the sessions valuable. Please share your feedback on social media using #AlwaysLearning. With this, I now hand over to the first speaker of the session.
Hello everyone. I hope each one of you are doing fine and staying safe. These are testing signs for sure. The world is evolving at a fast pace, and so is technology. Welcome to the world of technology. Welcome to the world of artificial intelligence. These are times where technology is having a very profound impact on society. I'm sure each one of us are dealing with technology on a daily basis. As a student, you may be attending classes online, and thanks to technology for making it happen. Now, if you look at industry in general, be it retail, be it manufacturing, be it healthcare, be it banking, finance, insurance, all of these industry verticals, there is massive adoption of technology, which probably was not the case 6 months back. The pace of innovation is truly at its acme, and industries are looking at how can technology make an impact to consumers, to businesses, and the overall well-being of society in general. If you look at the technology landscape, it looks like a dream lineup, be it artificial intelligence, big data, quantum computing, or blockchain. I'm sure as a student, you would have experience with each one of them in some capacity. Having said that, it is also a very, very interesting time in the industry where the pace of innovation is at its acme. It's also an interesting time to be a developer in the industry. The choice of technology, the power of technology to solve some of the most profound problems in the society is a reality today. More so in the current times where there is heavy reliance on technology to augment human ingenuity. Talking about human ingenuity, yes, artificial intelligence as a stream of technology tops the chart. If there's one technology which will complement human ingenuity, that would be AI. And AI is no small field. Number of innovations happening each day is tremendous. And to keep pace with each one of them is no easy task. As a student developer, if you want to stay relevant, you have to stay curious, right? Stay curious, stay relevant should be the mantra. And I have 2 important traits that I want to pass on, which will help you stay curious and stay relevant. Number 1, stay curious. It is super important for each of us to stay on the tarmac of curiosity in the current times. If you look at AI, I look at 2 trails right there. Trail number 1 is AI services, and trail 2 is AI frameworks. AI services, they are dominantly cognitive services, cognitive APIs, right? They're all black box store. That means they're all pre-built AI APIs, AI services hosted as APIs. You can take those APIs under the category of computer vision, language, speech, and look at infusing intelligence into your applications. First things first, right? Go to those sites where these APIs are hosted. There are wonderful demos available. Understand how these APIs work. Understand the power of these APIs. If it is a computer vision API, look at uploading pictures and see the insights you get from those visuals. If it's speech, today if you look at speech as a category of innovation under the stream of AI, we talk about neural text-to-speech and speech-to-text. That means the ability for machines to pretty much speak like human is a reality today. You have to experience it for you to believe it. Now, as I said, curiosity leads to experiencing technology, and it is absolutely essential if you want to strike big in the field of AI. Testing or each of those technologies is very, very critical, right? So AI services, you don't need to understand the algorithm behind the scenes. All you have to do is check them out in terms of the power it possesses today in solving some of the most profound problems in the society, right? I gave an example of social distancing earlier. Now, if you look at in the current times and going forward, computer vision will have a significant role to play. Unless otherwise you understand the power of computer vision, you won't be able to relate to the kind of use cases or scenarios these technologies will solve going forward. Another trait I mentioned is of AI frameworks. These are frameworks that will actually help you build machine learning models. Now, be it regression, classification, clustering, or forecasting, you will have to experience some of the algorithms under each category. On the trail of curiosity, it is important to understand the mathematical model behind the scenes so that you can appreciate the outcome from these algorithms in reality. Now take a category, now be it classification or clustering for that matter, right? So choose an algorithm and relate to some of the real use cases that this algorithm can solve. It can be simples of the problem, it doesn't matter. But your intent here is to understand how these algorithms work, and over a period of time, you will build intelligence to understand which algorithm will help solve what kind of problems. On the trail of staying curiosity, it is very important to ensure you experience some of the latest and greatest technologies in its purest form, and also start building awareness and get acquainted with some of the most popular algorithms under the umbrella of regression, classification, forecasting, or clustering. Very important. And if I can talk about one trait number one, which is stay curious, it is essential to experience technology as a method or a means to acquire knowledge. There is no better way to acquire knowledge than to keep experiencing technology. You might not understand what is behind the scenes, it doesn't matter, but it is important to experience it so that you understand what is the power behind the technology in solving some of the most real use cases in the industry. Number one, stay curious by experiencing technology as you see it emerge in the industry. The second trait I want to pass on is stay relevant. Having stayed curious, experiencing technology, it should eventually translate to continuous experiments one would do over a period of time. I'll quote my own personal example here. When I get to hear about a new technology, I read about it, and if there's an opportunity, I will build a simple hello world example right there. Just to quote an example, the camera that you see right behind me is the Vision AI Dev Kit from Qualcomm. When I got hands on this device, I built a simple hello world example just to understand the power behind the technology. Now, in the recent times, considering real-time use cases in terms of social distancing or to ensure that everybody wear masks, I use the same camera and build a machine learning model deployed to that camera to see if an individual is wearing mask or not, right? My experience with that technology as I built a Hello World program helped me understand the power it possesses to solve some of the problems in the society. So I took that experience of mine, applied to a real world use case as I experimented with that particular device. Now this is one example I'm quoting, but the point I'm trying to make here is you have to stay curious to stay relevant. And staying relevant is more than required in current times where pace of technology is skyrocketing. And as students, as you step into the corporate world, what will give you a competitive edge is pure knowledge. So my request to each one of you who have joined today is to stay curious, stay relevant. The best way to continue your experiments is to pick up datasets from either from Kaggle or any other open dataset repositories and build your miniature experiments based on the learning you've done as part of the Microsoft AI Classroom series. Thanks once again for joining in, and feel free to reach out to me on LinkedIn with any further questions you may have. I'll try my best to answer in my capacity. Thanks again and happy learning.
Thank you. Hi, everyone. Welcome to this module number 2 of this 3-module series. Hope you have attended module 1 and you recognize me. My name is Bhavesh Goswami. I'm the founder and CEO of CloudThat, and I'll be your instructor for this module once again. Along with me, I have Prathit and Anjali from CloudThat, and they'll be helping us with demos as well as to answer your chat questions. All right, so in case you haven't attended Module 1, a little bit introduction about me. My name is Bhavesh Goswami. I'm the founder and CEO of CloudThat. CloudThat is a worldwide learning partner with Microsoft. We recently won the Partner of the Year Finalist Award, to kind of for the trainings that we provided. We've trained over 2 lakh people worldwide. And before I founded CloudThat, I had a master's in computer science with area of specialization being AI and ML. And so I have varieties of publications and patents in this field as well. After my master's, I worked for companies like Amazon and Microsoft. And I really hope that I can bring some of my industry experience into this session and help you ramp up in your AI/ML journey. Really hoping that you all will take this knowledge, embellish your resume, and do great things to be able to get your career started in the AI/ML space. And we have a lot of other offerings for you as well, which we'll discuss going forward. Okay, so before we begin, in case you have not attended Module 1, or if you have and maybe it's not really fresh, in Module 1, we talked about the fundamentals of AI/ML, the data science lifecycle, how a typical data science project looks like, and we kind of dig deep into some of the algorithms. So we figured out what is the data nomenclature for an AI/ML project, like what's a attribute and what's the target attribute, feature, right? Training data, testing data, so forth, what's a model. So we had those data nomenclature done in the first part. Then we talked about things like decision trees, neural networks, clustering, and figuring out that they belong to categories of algorithm that can be classified as supervised, unsupervised, and semi-supervised, right? And then we talked about responsible AI, how to use AI responsibly. So really hope that you have kind of taken that module. If you haven't taken that module, but you know about these things, you are fine to take module 2. If you feel like, yes, I still don't understand what is supervised, what is unsupervised, right? And I would love to maybe do that. Then we have multiple executions of Module 1. You can still go back and register for a future execution of Module 1. And you can continue with this, but also go back and revise on Module 1. That will help you out quite a bit. Yeah, so with that, let's look at the agenda for Module 2. So last module was all about the fundamentals of AI/ML. This module we will kickstart with the Microsoft AI/ML platform. Right. So what does Azure AI/ML platform look like? What are the services do I have? What are the options do I have? How can I have my data science lifecycle on the Azure platform? Yeah. So we'll talk about some cool technologies available on Azure. The best service there, the most relevant service is one called Azure Machine Learning Service. It's an end-to-end data science lifecycle management service. You can, all the way from data to model, you can do the entire processing in that service. So we'll go ahead and talk a little bit about that, and we'll see plenty of demos, of course, as we go along. We also want to talk about the no-code environment. So there we have Azure Machine Learning Studio. We'll talk a little bit about that. The great thing is that a lot of times people come to us and say, I'm a student, I'm not good at programming, can I still have a career in AI/ML? And the answer is absolutely yes. There are a lot of no-code or low-code tools where you don't have to write so much code. You just kind of go ahead and use the tools available to you. It's always great to know a little bit of Python if you want to be in data science. So I'll highly recommend that. But if you don't know that, don't be discouraged. You can still, if you understand the data science lifecycle, there's still some opportunities for you out there. So we'll talk about the low-code solutions out there on the Azure platform. And then one of my favorite services, automated machine learning, automated machine learning, right? So automated machine learning, we can actually go ahead and a lot of things we have talked about or we will talk about today, it can be fully automated using that. And it's again a low code no-code environment where you can just drag and drop your solutions, and it will do the entire heavy lifting, all the crazy work for you, and save you as a data science professional a lot of time and effort and energy, right? You might, if you have done some data science project, you will see that what probably took you 3 to 4 months to do can be done in 15, 20 minutes using automated machine learning. So really cool prospect that. And we'll talk a little bit about visual designers available on Azure ML as well, right? So we have a packed session. Let's get started. All right. So before we begin, one more couple more instructions we wanted to kind of give you is that first, ask a lot of questions. If you have any doubt in the question, please feel free to ask. You have a Q&A box in your slides, in your tool rather. And the question you ask, we have a team here. My colleagues are available to answer your question as and when you have any questions. So feel free to ask questions. We'll be happy to answer them for you in this chat session. Post this session, let's say that as part of this session, we'll give a lot of go-dos as well for you to go ahead and practice whatever we are doing here to kind of be able to do all the demos that we are showing here. So the go-dos are, you'll have to homework. You hopefully you can finish it after the session. And if you have any questions with that, if you're struggling with that, any other question, take down this support email that is on your screen. And you can send us an email on this alias post this training, right? So take a screenshot of this, very important information. Just take a screenshot. If you want to take a photo from your camera phone and store this information because it's very useful for you. And you can get back to us using this email alias after the training, right? So during the training, Q&A box, after the training, this email alias to email us all your questions. Third, please visit this URL right on your screen. It has all the information available to you for this program. So for example, let's say this is module number 2, you didn't attend module 1, and you just heard there's a module 3 as well. So you want to know more about it, go to this URL. It will have the entire schedule. You have any question about. So after you finish all the 3 modules, our recommendation is that you can do some self-study, finish the go-dos, and then do an assessment to see where you stand. And you finish assessment with particular grade. You also get a course completion document which you can put as part of your resume. So great. So how do I get that? Go back to this URL. Any other question or about this program that you have, go back to this URL and you can probably find all the information there, right? So this URL is very important. Please take a screenshot. Please bookmark it in your system so you can quickly go back to it if you have any questions about this program, right? So with this, let's start. The first topic we're going to talk about is the Azure AI/ML platform. Let's look at what Microsoft has to provide for us in the form of the AI/ML platform for us to be able to do our data science. So here, first of all, we have something called as pre-built AI, right? So these are called cognitive services. Now, in cognitive services, imagine that, like we discussed in the previous section, that if you wanted to, let's say, recognize images, or if you wanted to analyze text or want to translate text, you'd have to create a model first, right? So you have to have a bunch of data, you'll have to create a model, and then you can consume the model. But here in cognitive services, it is called pre-built AI because these models are already created by Microsoft. So for example, you want to figure out emotions in a face. You want to upload a photo of somebody and you want to figure out what are the emotions in that face. Well, you don't need to create your own model. There are models already created by Microsoft and they're already exposed. You just have to go and kind of call this API and it will give you back the details about emotions in the face. Similarly, you want to do sentimental analysis in the text. Well, you just pass the text and it returns the sentiments along with all the information. So basically, pre-built AI cognitive services is something where all the models are created for you, pre-built for you. You have to call them using the APIs. Then we have the conversational AI, which is the bot service. So conversational AI and bot service. Bot services used to create chatbots, intelligent chatbots, which can converse with the users, which can solve some real world problems, right? And it's really, really easy to do. Then we have custom AI, which is the machine learning services. So Azure Machine Learning Service is a really neat service which allows you to create, upload your data, clean your data, create your models, deploy your models all in one. And this is something which we'll talk about, right? In terms of tools, we have the Azure Machine Learning for Visual Studio Code. So VS Code is the number one IDE on the planet. Visual Studio Code, right? It's totally free. It's available on Windows, Mac, Linux. It's the number one IDE on the planet, right? And we'll have a demo. VS Code is something you can use to do your data science project. You also have Azure ML Studio. This is basically a no-code solution where you don't really have to write code. You can just drag and drop and do data science without having to write a single line of code. You can do end-to-end data science from data cleanup to creating models to consuming models, all without writing a single line of code. So this is something which we'll demo in. Then you have the Azure ML Workspaces and so forth, right? You have, and on the AI on data, you have basically, if you really wanted to use raw power of Azure and not the tools, you can also create your, start your virtual machine in the data science virtual machines or deep learning virtual machines, and you can use your, things like Cosmos DB or Data Lake to be able to create your own models. But that's, more if you really wanted more customization and you just wanted to create your own platform. And stay tuned with us, and kind of we'll have a demo and hands-on lab on all of this. Also, Azure AI/ML platform supports all the major open source platforms like TensorFlow or Caffe or Scikit-learn, right? It also has a cognitive toolkit, which has a lot of these libraries bundled. So you can use that as well if you are interested. But this is a really great platform for you to do end-to-end data science, whether that is using cognitive services, bot, or your custom AI. So like I said, we'll have a lot of hands-on demo throughout this.
So the first concept here is that of a workspace. So what's a workspace? It's a top-level resource for Azure Machine Learning Service, Azure ML Service. So before I can do anything, I need to create a workspace, right? And it serves as a hub for building and deploying models. So you can imagine that if I have, let's say, if I'm a data scientist for a corporation and I'm helping two teams generate models, team A and team B, and they are totally disjoint, right? The data is different, my techniques are different, then I'll probably create two different workspaces, one for team A and one for team B. That way all my data, my resources, my models are totally isolated from each other, right? Similarly, the workspace stores experiment objects that require for each of the model. It can save compute targets as well. It can track training runs, retrieve logs, metrics, and so forth. So basically think of it as a high level workspace. You're used to it. If you're a developer, you are used to it in something like, Jupyter Notebook or in the Eclipse or VS Code or something like that. This is a similar concept over here. Right, then we have a data store. So data store is an abstraction over Azure storage account. Basically, like we have discussed, that if I want to create a model, right? To create the model, I need data. And the best way to get the data in Azure ML service is to get it from Azure storage, right? And so which is Azure storage account, Azure blob storage, or Azure data lake or something. So a data store encapsulates that and kind of provides you a way for you to import data and to generate a model from that, right? So you can register other blobs, Azure blob or file storage containers as a data store as well. Next is a pipeline. So what's a pipeline? Machine learning pipeline is a tool to create and manage workflows during a data science process. So it's basically right from getting the data, right? So here's your data storage options that we're going to go ahead and prepare the data, right? Normalization, transformation, validation, featureization, all of that is happening over here. Then once the data is prepared, we build and train models, right? And finally, when the model is made, we want to deploy the model. And the model is deployed because imagine the data set we've been using for the past 3 days, the New York yellow taxi data set. Once we have created a model to predict the fare, maybe we want to expose it so that it can be utilized by the company to determine the fare for people before they can get into the taxi. So they can have an app where somebody can put the pickup location, drop off location, and it detects the fare for them, right? So basically this is something where so basically this is where you kind of deploy the model and then it's consumed from it, right? So this end-to-end set of and by the way, when you deploy a model, right, it generates more data, which again can be factored in and put into the data location, and we kind of recreate the model over and over again. So this is a pipeline. A pipeline is from data to a model to deployment, all the way end-to-end pipeline. So here an Azure machine learning service is basically all of the above, from training model to deployment to model management. It has services to kind of give you end-to-end data science process management, end-to-end data science lifecycle management into a single service. So a super powerful, super efficient service to do all your data science.
Azure machine learning service. Now, Studio is usually drag and drop, but ML machine learning service is a full gamut of solution. It's a full engine, right? It supports everything basically. It supports import of data, cleaning of data. It has a visual interface. It has notebooks. You can provision your own hardware to run your experiments. So it's a really sophisticated end-to-end data science lifecycle management tool. So right from preparing data, right to building the model, and then training and testing your model to make sure that it is correct. Then you can actually go ahead and deploy it by registering the model, right? That this model is good, I'm registering it, and you can go ahead and deploy it after building the image. So it's an end-to-end from data to deploying the model, highly flexible, supports varieties of libraries, right? And it also has automated machine learning, right? Automated ML, which allows you to automatically create models from the data without having to do a lot of work. So that's brilliant features of this. And again, we'll see demo of this. So it can do model management, it can do model training, model selection, hyperparameter tuning. We'll talk about some of these concepts maybe in the next modules, right? But there's a lot of stuff that it can do for you automatically without you having to do much, right? So data, my data set, but how do I start, right? I want to get my hands dirty. I really want to learn. I want to do some hands-on. So how do I start? What's the development environment required for data science? So here we have a lot of options. And the first option so there are a lot of options here, right? The first options we're going to talk about are Conda and Jupyter Notebooks. The Jupyter Notebooks are really fantastic, as we'll discuss. They actually have an inbuilt environment where a lot of libraries are there, and you can really start and get going really, really rapidly. So we'll have a demo coming up for that, right? Which is the Jupyter Notebooks. Then you have Azure Notebooks. So Azure Notebooks are hosted Jupyter Notebooks, right? Where instead of Jupyter Notebooks that run on your laptop or desktop, right? Azure Notebook run in the cloud. We'll talk a little bit about this and show a demo of this as well in the next section. Then you have the data science virtual machine and deep learning virtual machine. In this, you can go to Azure and create your own virtual machines, which has this library, and you can run your data science projects over there. Right, and you have the cloud-based notebook VMs. This is part of the Azure ML service. You have Machine Learning Studio or Visual Interface and Azure ML Studio, right? And then you have the ML service, Machine Learning service, which also can be used for development. So let's first look at the Jupyter Notebooks. These are probably the most popular way of doing data science on your own machine, right? So let's say, I hope you all have Azure accounts. It's if you don't have it, it's really simple to create an Azure account, please do. But let's say for whatever reasons, you don't have an Azure account and you want to do data science on your own laptop or your own desktop, then you can use Jupyter Notebooks very easily. This is very easy to install, as we'll see, right? You can just go ahead and install it. It's open source. right? So kind of it is free for everyone. You can just download and start using it. Originally written for Python, but now supports a lot of languages. There's a lot of language support, a lot of cool stuff in it, right? And so basically Jupyter stands for Julia, Python, and R, right? Julia, Python, and R. And over 75 programming languages are supported, right? So the name is to emphasize multi-language support. And like I said, it supports a lot of different programming languages. So you have Jupyter Notebook. You can very easily install it and get going. So we'll see a demo of this going forward, right? So as I said, let's check out what Jupyter Notebooks are and how you can install them locally on your machine, on your laptop or desktop, and you can start doing data science on this very rapidly. So with this, let's see a demo on getting started with Conda and Jupyter Notebook.
Thank you, Bhavesh. Let's quickly jump into how to set up Anaconda and Jupyter Notebook. Anaconda is an integrated Python data science development environment which can be downloaded from anaconda.com. It is available for all three operating systems, Mac OS, Linux as well as Windows, and it supports the Python version. The beauty of Anaconda is when the Anaconda is downloaded and installed, it comes inbuilt with development environments like Jupyter and Spider, as well as it also brings in libraries, machine learning libraries like NumPy, SciPy, Pandas, Scikit-learn, Dask, Numba, TensorFlow, and Theano. So you don't have to spend any additional effort in installing these libraries. When you download and install the executable, it will install a software called Anaconda Navigator in your laptop. If you can see, Anaconda Navigator brings in Jupyter Lab, Jupyter Notebook, and Spider with itself. Let us go quickly, and for this demo we'll focus on Jupyter Notebook. Let us launch Jupyter Notebook. When you launch a Jupyter Notebook, it opens up a browser and the directory structure from where of the home directory of the logged in user, right? As my notebooks are in NYC dataset, I can navigate through there, correct? If you see, there are mainly 3 tabs in this particular UI. There are clusters, which clusters tab lets you know whether there is any Jupyter Notebook cluster for parallel processing is running using IPython parallel library. If there are any terminals running with Jupyter, if there are any notebooks running with Jupyter, and with files, you can see the explorer of the particular folder. By clicking on new, you can either create a new notebook or can create a text file or a folder, or you can initiate a terminal in this particular folder where you are, the folder that is explored currently on the browser, right? Let us create a notebook and rename it to, let's say, my first notebook. My first notebook. If you can see, as soon as a notebook is loaded, a cell is created. Now a cell is a place where you can either write some information about the project and convert it to markdown, and you can just have it there just to make people understand what the next line is doing, what the previous line has done, correct? And you can also run code here. If you see, when I executed the code actually shown the output, correct? As Bhavesh earlier mentioned, this is a smart IDE. It makes our life easier to share information with someone when we want to share the code and the output, both of them together. Let me show one more notebook. As you can see, I have created I've added some information. I have imported several libraries. I have asked the notebook to bring in some data from train.csv. I have asked the notebook to display the data, and you can see the output is also displayed. I can not only display the data on the Jupyter Notebook, but I can also plot nice, beautiful charts on the notebook itself. Correct? This makes my life easier when I am trying to explore the data and share the exploration or share the findings with someone. When I send the notebook, it will take this particular diagram along with itself to someone else. With that, I hand over the session back to Bhavesh.
Right. So the next one is Visual Studio Code. Right. It's a smart IDE. And by the way, the demo that you saw, it's just the same thing that Jupyter Notebook supports. You can also, there's a Jupyter Notebook plugin for Visual Studio, as there's a notebook plugin for Visual Studio as well, Visual Studio Code as well. So you can download the notebook plugin and get similar interface to what you saw in Jupyter Notebooks as well, right? So it has, Visual Studio Code, right? It's a smart IDE, it's an IntelliSense, syntax highlighting, integrated debugger, integrated Git, right? 17 language supported. So it's really, it's the number one IDE on the planet for major platforms like Windows, Linux, and Mac are supported, right? So you can go ahead and do your data science on this as well. You have to download a couple of libraries to be able to do that, or a couple of extensions rather to do that, but that's pretty simple. So without further ado, let's see a demo of how you can use Visual Studio Code to do your data science experiments.
Thank you, Bhavesh. Now let us move to the next demo. The next demo that we are going to talk about is how to set up Visual Studio Code to run the same Jupyter Notebooks that you have created, right? Let me quickly jump to how to download Visual Studio Code and install it. When you go to code.visualstudio.com, the site will tell or will prompt for the download package for your operating system, be it Mac, be it Windows, be it Linux, whatever operating system you are logged in, it will immediately give you a download link for that. If you want to see what type of installers are available, there is a link to go to look at the other installers. You can look at them and you can download the corresponding files. Once your Visual Studio Code is downloaded and the executable is installed, your code will open up like this. Correct? You can see that there is an explorer for multiple folders, there is a search, there is a git link directly, there is a debugger inbuilt, and there is a extension marketplace. If you see, there are multiple extensions available for now. For our purpose, I have just installed Python and Jupyter extension so that my Jupyter Notebooks can run and I can write Python programs. If I go back to the Explorer and if I click on new file, I can create a notebook file with, as I previously mentioned in my previous demo, IPYNB extension, and that will become a Python Jupyter Notebook. If you give a little time to Visual Studio Code, it will create your Jupyter Notebook. You can create cells there, and similar way you can run the command in Visual Studio Code. Similar to Jupyter Notebook, you can also present some markdown characters here. You can also write information. To put it as a markdown, you can just put percentage and it will work as a markdown for you. With this, I hand over the session back to Bhavesh.
All right. So both now, the next thing we're going to talk about is the Azure Notebooks, right? Now, as you can understand, so imagine that this is my laptop, right? And in my laptop, I'm actually going ahead and installing either the VS Code, or I'm installing Conda and using Jupyter Notebook, right? As you can understand, it is consuming the CPU, RAM, and the hard disk of my machine, right? My laptop. So while the experiment is going on, my machine might get slow, it'll consume my CPU. But what if you don't want to do that because your machine is not that powerful, or you don't want slowness in your machine while the experiment is running on? In that case, you can use Azure Notebook. So Azure Notebook, it basically Jupyter Notebooks, but it is hosted on the cloud. So instead of so let's say you have an experiment, when you click run, it consuming your CPU and resources. The notebook is virtually created in the cloud. And when you say run, it actually consumes cloud resources, right? So it doesn't really it doesn't take up resources from your laptop, but resources in the cloud. It is stored in the cloud. So if your laptop crashes, your notebooks are still safe. And best of all, it is absolutely free, right? So you don't even require a credit card or anything like that to create an account. So Azure Notebooks, a really great way to do your Jupyter Notebooks workloads on the cloud, totally free of cost, right? So with that, so basically it's as you can see, it's a screenshot. It looks very similar to Jupyter Notebook. In fact, it's powered by Jupyter Notebook, right? It says, and it's fully on the cloud. You can just go to the URL that we'll see in the demo and create your free account, right? You can see the cells contain code annotations and the same features you have with the Jupyter Notebooks you have in Azure Notebook as well. So let's see a demo of how you can create an account for Azure Notebooks and go ahead and run some data science experiments over there.
Thank you, Bhavish. Let us see Azure Notebook. Azure Notebook, as Bhavish mentioned, is a Jupyter Notebook hosted by Microsoft Azure on cloud. For this, you will need a Microsoft account. If you don't have a Microsoft account, you can sign up for a Microsoft account by signing up in Outlook.com or Live.com or Microsoft.com itself. If your organization is already running Office, already having an Office 365 account, don't worry about it. You already have a Microsoft account. What you need to do is you need to log into your Microsoft account and then go to notebooks.azure.com. On notebooks.azure.com, it will ask you to sign in. If you are already logged in with Microsoft account, it will just ask for the permission that it requires. And once the permissions are given to it, it will definitely take you inside and will ask for a profile name for yourself. You can define a username for yourself and you will end up on the My Profile page. On the My Profile page, you can see that I do not currently hold any project, right? So let me create one project now and name it My Project 1. I'm not making the project public. If I make the project public, a public URL will be associated with the project, and if I give the URL to anyone, they'll be able to look at my project. They'll be able to modify my project based on the permissions given. Azure Notebook also gives us a way of initializing a README file. However, the README file will not have any content. We can choose to initialize the project with README file or not. Let me create the project. Once you create the project, you will be taken to the project window. Now, if you see, currently the project is in stopped state, correct? You can run the project by running it on a free Azure Notebook compute, or you can choose a dedicated Azure virtual machine which will run your notebook on your behalf. That you can provide by selecting direct compute. For now, what we will do is we will run it with the free compute. As soon as you run, if you see, similar to on-premise Jupyter Notebook, this will pop up another window and will show up the tree structure for the folders, for the project folder. And if you see, it is the exact same UI, right? Only advantage we get with Azure Notebook is that when we saw the local deployment, we only had one kernel or one type of environment. Whereas with Azure Notebook, I get F#, I get Python 2, I get Python 3, I get Python 3.6 as well as R for the environment. Along with the basic files that I can create, that is text file, a folder, or I can run a terminal in here, correct? Let me go ahead and create a Python 3 notebook, and we will name that notebook as my first Jupyter Notebook. Similar to on-premise Jupyter Notebooks, this also comes up with a cell, and the same thing, you can convert a cell into Markdown to provide some annotations, and you can also write code and execute the code to see the output. Let us upload an existing notebook that I have created to Azure Notebooks. To do so, click on the upload button, select the notebook that you want to upload, and just click on open. When you click on open, it will ask you to give the name to the notebook. Just verify the name of the notebook and click on upload. Correct? Your notebook is uploaded. With that, I hand over the session to Bhavesh.
Great. So the next tool that you're going to use for a data science is the Azure Machine Learning Studio. This is also called the Machine Learning Studio Classic now, right? Because that's kind of the older software, I guess. But the great thing about the Azure Machine Learning Studio is that basically is no code solution. It's a visual drag and drop for training and deployment. You literally don't have to do anything. You just have to just drag and drop a few things, and voila, you get your, your entire, project there. You can just right click and deploy the project and start consuming. So for people who are not good in programming or don't really want to do a lot of programming, right, but still want to do data science, this is a wonderful, wonderful tool for people who want to go ahead and do that, right? It's a complete machine learning environment and ideal for beginners and data scientists. So if you're a beginner, don't have strong coding background, this is the tool for you, right? As you can see that, so the demo of this will start. And here you can see you have various components. You can have projects, which you can create a high-level project. Inside the project, you can have experiments and so forth, right? So here also you can have notebooks, and you can run your notebooks here on the ML Studio. You can also drag and drop your components. So more on this in the next session.
Okay, so what's the workflow for a data science project? Here, the very first thing that we'll have to do is, like how we've been talking about, that data is the most important part. So the very first part is definitely figuring out where the data is, collecting it, and importing data for our project. So that's typically going to be importing data is going to be the very first step. Then it's going to be about exploring and creating summaries. We really need to understand the data before we can do anything meaningful with it. So we'll see a lot of example of that. You'll see a lot of hands-on on how to explore and visualize your data. Then about pre-processing and cleaning the data. Data can have a lot of, it's very rare that you will get data which is really pre-processed and clean for you. Usually there will be some anomalies in the data, so you'll have to clean it. Then we select the algorithm. Then comes model tuning and training.
And then in the end, we're going to go ahead and deploy and consume the model.
Correct. So when we'll try to explain different kinds of data manipulations, we will require data set to actually do those manipulations. We're going to use a data set, and this data set is called New York Yellow Taxi data set. Basically, if you have seen, if you have been to New York, that's great. Or if you haven't been, you must have seen movies shot in New York, and you see this yellow taxis running around all over New York, right? So surprisingly, they collect really good amount of data. So every taxi ride that you take, some amount of data is collected from the taxi ride, and that data is accumulated for us and provided to us so that we can do experimentation on data science. So this data set is called Yellow Taxi data set. This is the data set about the pickup, drop off and fare from the various taxi rides that people have taken. We have, I think, about 4 or 5 years in this data set, and there are about more than a few million entries on this, right? So pretty large data set. This is provided to, so we have used this data set from a website called kaggle.com. It's a website where a lot of people upload their data set to explore. There are also challenges where you can go ahead and participate in a challenge and so forth. A good way to kind of get your feet wet in the data science process. So if you want to start learning it, it's a good website called kaggle.com. So from there we got this data set. So let's look at it. So of course I have only shown 5 rows here, but you have more than, you have few million of such rows, right? Okay, so what does the data look like? Here, the key is a unique value for the data set. So you can think of it as a primary key, uniquely identifying each and every row. Then it's the fair amount. So fair amount is how much in US dollars, how much money this particular fair trip cost. So for example, this fair trip cost $4.5 for the riders, whoever wrote this. Pickup date time. So this is the date. You can see this is 2009, right? Date. And on this date, they did the pickup at about 17:26, which is about 5:26 in the evening. So this is when the trip started for this person. Then we have the pickup longitude and pickup latitude. This is the lat long, the exact geolocation from which the trip was started. So the taxis are fitted with geolocation, sensors to kind of monitor and tag geolocation. So basically, they notice that the drop of lat and long, the lat and long where they were dropped off, and the passenger count, right? So what is the purpose of this data set? Basically, on Kaggle, there's a contest to say, can you create a model which can accurately detect the fare amount? So if you have used some of the modern radio taxi companies like Ola Cabs or Uber, you know that before you take the cab, right, they give you an estimate of how much your fare will be. Right, so they have to basically create a model where I put my pickup location, I put my drop off, and they give you an idea of how much it's going to cost you. This is really convenient because sometimes, I'm contemplating between, hey, should I ask, let's say I want to go from from work to home in the evening. I'm thinking, should I ask my coworker for a ride? Should I walk? Should I, take a taxi? What should I do? So if I look at the fare, sometimes it helps me determine if I should take the taxi or not, right? So let's say New York taxi company also want to have that kind of predictive model, which can predict how much the fare amount is going to be when somebody can maybe put pickup location and drop off location, right? So if you remember from yesterday's session, the fare amount will become our target attribute. This is the attribute we're trying to predict given the other attributes, right? So that's going to be the use case you're going to drive for the next couple of days. And today we're going to do EDA on this data set, right? So essentially, like I said, here I've only displayed 5 rows, but we have more than few million rows of this data set available freely to us from kaggle.com. All right, so with that, let's proceed. So the next step is to import the data. Now, before we can run any experimentation, whether that's in Jupyter Notebook or on Azure ML Studio or Azure ML Service, first we have to get hold of the data. So like I mentioned, the data is available to us from this website, but we'll have to still import it into our system, into our development environment that we selected. Here, what are the options I have? And by the way, the kind of data sources possible is good to know, of course, if you want to do data science on Azure, but it's also some important from examination perspective. You do get some questions from this kind of data sets. So what are some of my data sources? First thing is the Azure Blob Store. This is probably the most comprehensive, most easiest way that you can access data. So let's say in this case, the data is available on our website, we just go ahead and from that we upload the data to the blob store, and then we can directly start using the data from the Azure blob store, right? And because the Azure ML Studio and Azure blob store will be in the same infrastructure, right? Same Microsoft infrastructure, you'll probably see that it's going to be much faster to access data if it's in the Azure blob store. So that's one way of importing data. The second way would be to use a web URL using HTTP. So you can directly pull whatever the URL the kaggle.com has given you. You can directly take that and you can pump that, and you can directly go ahead and use that to do our import the data. So that's the thing. Now remember that if you use that, the data is streamed over the internet and to your whatever development environment you have chosen. So it might take some time. Then you can have data on Hadoop using HiveQL. So HiveQL gives a table-like structure to your data on Hadoop, and you can use that as well. Then you have Azure Table Storage. So this is something where in table storage, your data is stored in NoSQL format. So if your data is in Azure Table Storage, you can do that as well. And then Azure SQL database, right? So a lot of times the data we use is in the RDBMS format. So in the previous section, when we look at data set, so I'm going to go back for a minute. In this, you can see that this is a nice structure, right? This is nice. You have the columns nicely defined. The columns have a type. This is text, for example. This is a number, right? This is a date, time, and so forth. So this is nicely defined. So maybe you could have, the first step could be that you have injected this data into a SQL like environment as well, like Azure SQL, right? So that's maybe the first thing you have done. And then from there also you can access the data in Azure ML Studio. Okay, so that's the Azure SQL database. Then you have SQL Server on Azure VM, right? You can have an Azure VM which is running SQL Server. You can also have on-premises SQL Server database. So in Azure Studio, you can go ahead and import data on-premises server through something called as data management gateway. Something to remember, important for examination perspective. You might get a few questions that if your data is on-premises, you can use and you want to create your model in Azure Studio, then you can use something called as data management gateway. Okay, so what are some of the things that we need to understand, right? Basically, in data science, understanding data is a very, very important point. And so you'll usually see that data scientists either they are the subject matter expert on the domain. They're the domain experts, right? Or they have a domain expert with them to help them understand the data. But luckily, this is a very understandable data set, taxi data. So literally all of us are subject matter experts on that because all of us have used taxis in our life, right? So let's see what we can understand from this data set. So I put a small kind of image of the data set over here so we can reference it. So here we can see which, for example, which features show independent dependent behavior, right? Are there things which are dependent on each other, and what are the things which are independent? So you can probably very easily, because you have domain knowledge of taxi data, you can probably imagine that so the fair amount is our target attribute. We want to predict that, and you can probably imagine that the fair amount is directly related, right, to something like the distance traveled. So if you have the lat up, the pickup lat long, and the drop off lat long, you can calculate the distance. That is probably going to be directly related to that. And something like passenger count, right, is going to be totally not related to distance. So the distance traveled doesn't really have any direct relationship with the passenger count, but fair amount might have relationship with the passenger count, and fair amount might have relationship with the distance traveled, right? The fair amount probably also have some relationship with the pickup date and time, because sometimes at night you pay slightly higher. In the rush hour traffic, you sometimes pay more because you're stuck in traffic, right? So this kind of thing, this data set is very simple because it's only about 4 or 5 or about 6 to 7 features, but sometimes you can have hundreds of features, right? And sometimes the features are also not as easy to understand. So you can run some analysis on which features are dependent, which are independent. We'll talk a little bit more about that today and tomorrow, right? Which features contains outliers, or do features contains outliers? So again, we'll see some tools and tricks in the later half to kind of identify what are the outliers that we have, and we can probably very easy. Some outliers are easy to find. For example, let's say the fair amount. If the fair amount is negative, it's very easy to understand, hey, this is an outlier. But what if a pickup lat long is an outlier, right? It's there by mistake. That's probably going to be harder to find by humans just by looking at it. Then maybe we need to do something smarter about it to find outliers in lat and long. Are there features which only add noise if used for training a model? So you have to also figure out what features to use for modeling, right? So you can probably understand that key, the role of the feature or the attribute key is to give a unique identifier to each and every row. Probably there is nothing meaningful in it to help us create a model. So if I'm creating a model, then potentially I should not be using key as one of the things I pass on, because as you can probably predict that the fair amount is not related to the key at all, because the key is date time, yes, but it's appended with a random number at the end, right? So this 00001, and most algorithms will take this entire value as a unique value, and so this unique value probably doesn't have any relationship with the fair amount. So if you're trying to predict fair, we probably should not use the key in that, right? Are there any trends, patterns, or biases, right? And so this is again something which we'll look in the later half. There are some tools and tricks and tips and some kind of graphs which we can use to figure this out, right? And why attributes, if there's any attribute which has missing values, and if it's that's a good reason for it. Now you can imagine that when somebody picks up, right, when the pickup happening in a taxi, probably there's an automated system that when the cab driver hits pickup, right, it collects the lat and long. But what if your GPS sensor at that time is off, right? Maybe you are in a basement where there is no signal, or there's something wrong with the sensor and it's not able to pick up lat and long. Then it might be 00 as well, right? Or it might be blank, totally blank at all. So that there might be missing values in a lot of this, and we will have to clean it, right? So this is kind of like the basic thing we're going to be looking at, and we'll dig deep into it in the next few sections of this program. The other things we want to see in this is which values are the most common, right? So here are the values which are most common, and when we see in the later half some different kind of graph, those graphs are very important to find that out, right? So if you're trying to predict the fair amount, it might be that some values are more common than the other, which will help us. Which values are rare and why? So so for example, let's say this radio taxi company only works from, let's say, 4 in the morning to 1 in the night. Then there won't be any values in the pickup date time, which is between that time zone, right? So you can figure out that, hey, this is something, these values are not there because the taxi company doesn't work in that. It could be that the minimum fare, let's say, is $4. So you will see that there is no value below $4, and that also tells us something about the data. Are there any unusual patterns which may explain them, and what might explain them? So again, we'll talk a little bit more about that in the next section. How are observations within each cluster similar to each other? So if you have some observations, right, fare and stuff like that, are they similar to each other? What's going on? Again, we'll talk a little bit about that in the next section. And how are the observations in separate clusters different from each other, right? So we want to make sure that we look at the data, we really understand the data, and the tricks and tips to understand the data is coming in the next section. So here, one of the first thing we do is we're going to go ahead and look at some of these things like identify unique and missing values, right? So for example, for all, now I've only plotted 5, but you can imagine that if we have few million of these entries, then we'll probably have to run some code to figure out are there any missing values and what do we do with that? What's the minimum and maximum value, right? Especially for the target attribute. And there's things like correlation plot, box plot, and scatter plot. So we talk about this in the next few slides. Okay, so the first one that we're going to dig deep into is called the bar graph, right? So bar graph, just remember that is useful for plotting discrete values, right? So imagine that yesterday we talked a little bit about saying, let's say we want to make an algorithm where we go ahead and figure out if an individual should be given a loan or not, right? So probably one of the very important factor in giving somebody a loan and figuring out if they can repay or not is the current employment status, right? Now these are, as you can see, these are discrete values. These are not numerical values, right? These are discrete values. And so for discrete values, the only thing that kind of meaningfully you can plot is something called as bar graph, right? So you can see that you have employed, so majority of the people that are there are employed. Then there's employed full-time, right? So majority of them are employed full-time. Self-employed, not available, so they refuse to mention other, part-time, not employed, and related. So this is the kind of summary of our data for something like that, where something like yesterday, where we are trying to create trying to figure out if somebody should be given a loan or not, right? So bar graphs are, just remember, are used for, or very useful where you're plotting discrete values. Now look at the histogram, right? So histogram is extremely important to understand our data, and this is for continuous value or continuous variable. So let's look at so again, going back to our example of New York taxi data. From those, we have taken about 1 million records, and we are trying to plot the fare in USD, right? So what was the fare that they played, and the number of trips that had that fare, right? Now, as the fare is a continuous value, if I use something like, so if I go back and if I use something like a bar graph, right? So bar graph, each unique value is its own kind of column. So if I did that with fare, you can imagine that I will not have a meaningful plot, because what's going to happen is, all the fares are different. So there won't be any meaningful distribution of data which I can do. And that's why I use histogram. So what histogram does is that it divides the data into buckets, right? So you can see that here, there is nothing which is showing up here below 0, of course, right? So the minimum fare, maybe it's, let's say, $3. So the first bucket probably is between $3 to $4. The next bucket is from $4 to $8, from this to this. So it creates discrete buckets, right? From A to B, from B to C, C to D, and so forth. And you group the data into this bucket. So you can see that majority of your data over here, right, is between, let's say, about $5 to, let's say, if you go here, about $10. So majority of the people paid between $5 to $10, and that is very useful because we are trying to predict the fare. So knowing that vast majority of our trip fare are between these two values really help us in predicting the fare for the future, right? The other important thing histogram shows me is that you can see there are some bumps over here, right? So it is easy to understand. Most people take taxis for short duration, right? So the fares are much less. The majority of them are between, let's say, $4, $5, and $10, $15, right? Very few guys take long trips after $10, right? And so around, let's say, $40, $45, you see that there's almost a flat line, but there's a bump around $45. There's a bump around $50. There's a bump around, I would say, about $55 or so forth, right? So this is useful to see as well, because this probably means that there's some flat rate thing going on. So it might be that from New York city center to airport is flat $55, right? And New York has 3 different airports. So you can see that 3 different, and those 3 are at different distances. There's JFK airport, LaGuardia airport, and so forth. So it might be that each of this bump that I see corresponds with one of the airport and a flat rate for those airports. So that will be good for me to know as well when I'm predicting the fare, because I probably, if my destination is airport, I might need to do something special with it, right? So histogram is showing me where my data is, right? What is the most common fare? Some bumps here, which I've identified, might be some special case fares and so forth. All this with just one plot, right? So histograms are extremely important, used a lot to understand your data. So by plotting this, we have understood few things. First, majority of the trips are short. Secondly, there are some special fares going on as well, and definitely more people take shorter trips than longer trips, right? Okay, so that's kind of histogram. So now there can be 2 kinds of skews in data. One is called negative skew and other is called positive skew. So if I had to draw the shape of this histogram, right, the shape will probably look something like this, right? And you can see that it is more like the positive skew, where more data is towards the left of the median, which means that there are more values towards 0 than towards the extreme, right? And which means that when we are predicting, when we write an algorithm, we'll have to make sure that the values it predict has to be, more values has to be towards the left of the median, right? So that's something that we'll have to keep in mind. So in this case, the skewness of the data also tells you something about the data, in which case it is showing us that more people are taking shorter trips than longer trips. So next thing is preparing and cleaning the data, right? So a very important step, because a lot of times the kind of algorithm you want to use, you'll have to massage the data a bit to make it malleable and acceptable for the algorithm to take that kind of data. So the first thing is cleaning up the missing data, right? So imagine that in our data set that we looked in the taxi data set, there were some data points where, let's say, the number of passenger was missing. So what do we do with that? So we have a few things we can do to clean up missing data. The first is, the easiest one to understand is probably custom substitution value. So maybe I say that because one passenger is the most likely scenario, right, which is the most likely used thing, where the passenger is 1 is the most highest frequency of that, maybe wherever there's a missing value for number of passengers, I just put 1. Second thing I can do is replace with mean, right? So mean is an average, so I can replace with mean in some cases. Now just remember that it might not always be the right thing to replace with mean, because the average of the passenger will probably be something like 1.20 or something like that, right? So putting 1.20 passenger doesn't make a really lot of sense, because passenger can be either 1 or 2 but cannot be 1.2. So replacing with mean will make sense in some of the variables but not probably in other. Second is replace with median. This probably makes sense in our data set as well, because median is the 50th percentile, and as it's all continuous values, it probably will be either 1 or 2. So it will replace with 1 or 2, whatever the median is. Replace with mode. So again, mode is the most kind of prevalent value, and so probably that's something which also going to be work. Other thing I can do is, if I'm not so sure what to do, I can remove the entire row. This is useful when only, let's say, a very small percentage of data has missing values. So only, let's say, 0.1. Like we said, in this data set, we have over few million data sets. So what if 100 entries have missing data? Hey, just remove the 100 rows. It is not going to change the characteristics of my data. I have so many data points, I might as well just remove them and be done with them, right? So that's something you can do. Remove entire column. This is pretty extreme step, right? But this is probably you probably do this when there is a lot of data missing. So let's say that just to kind of give you an idea, I'm drawing a data set here. That imagine I have 1,000 rows. So I have rows 1 to 1,000. Right, and this is the data coming from something like a sensor, let's say, right? So you have lots of attributes coming in. Now there's one particular attribute, let's say attribute number 800, right, where let's say 70% of the values are missing, right? So if I do replace with mean, median, mode, any of these things, probably doesn't really make sense, because 70% of data is missing. 30% of data is going to populate 70% of the data, so it doesn't really make a lot of logical sense to do that. But also doesn't make sense to remove the row, because then because 70% of this row is empty, I'm losing 70% of the data. In that case, maybe I say remove the column. So by removing one column, I have a lot of columns, right? By removing this column, I still retain 999 columns, right? And I don't have to remove any rows. So that could be a logical thing to do for some of the data sets with missing values as well. There are two more advanced versions of cleaning the data. One is called mice, right? And what mice does is that basically instead of replacing with mean, median, or mode, it goes ahead and models, right, that value. So for example, let's say we have something like passenger. Maybe it can model and can identify that what some pickup places like downtown, where you will have mostly young professionals just running around in taxis. There's more likelihood of them being the number of person being one, and some locations more like suburbs will have a family of 2 or 3 taking a taxi. So maybe depending on the pickup location, it can identify automatically and fill the missing values, right? So mice can do that. It can model automatically and fill automatically the missing values based on the other values. So you are looking at other values you have and trying to fill the missing value. Similarly, you have replaced with PCA, Principal Component Analysis, probabilistic PCA. And what again this does is that it tries to see, it creates a linear model, right? And it analyzes code relationship between columns, right? So again here you can imagine that similar to the pickup location, let's say we had a time of day where during the rush hour, right, most people were just taking the taxi themselves. So it can figure out that the time of the day is directly dependent on number of passengers, and depending on that, it is going to go and fill the value. So basically, mice and PCA both doesn't replace with a single value. If you have custom substitution, mean, median, mode, and anything else, all missing value rows will get a single value. Whereas in mice and PCA, probabilistic PCA, you can get different values for the missing values, right? So that's how we clean them.
All right. So thank you, Bhavesh. Now, as we have seen, we have visualized our data. Now, we will clean the missing values so that our model can analyze the data correctly, right? So basically, we are going to add 2 modules in our experiment. So the first module will remove the normalized losses column completely, and second module will remove any row that has missing data, right? So now first I am going to add these select columns in data sets to remove my normalized losses column, right? So here you have to type select columns in data set. So in the manipulation, you will find this module, drag and drop here, right? Now, connect your automobile price data from this select columns in data set. After that, click on your module, select columns in data set module, and here you will find launch column selector. So click on this Launch Column Selector button. Now this Select Column window will open. What you have to do, in the left corner, you will find two rows, by name, with rules. So we will select with rules, right? And begin with all columns. Now here we are excluding the normalized losses. So we will select exclude with column name normalized losses. So select the normalized losses from the drop down and then click OK. Right? Now basically this module will pass through all the columns from the data set except normalized losses. So what we will do, we will run our experiment till here. So run your experiment so that your data will come on your second module. Right? Now we have removed entirely the normalized losses column. In the second module, we will select clean module data for cleaning some missing data, right? So here we will type clean missing data. So in the manipulation, you will find this module, drag and drop here, right? After that, connect this module, select column modules in dataset with clean missing data, right? All right, now click here. Here you will find one another properties blade will open. So basically here we have to specify that clean the entire row where you will find the missing values, right? So I will recommend you to put this missing value 0, maximum missing value ratio 0, and here in the cleaning mode, select remove entire row, right? That's it. Also, if you want to add comment to your module, you can also do that by right-clicking your module. So when you right-click your module, here you can also edit comment like clean missing row, right? So you can also add comment here. After that, run your experiment. So basically what we have done from the data set, first we have removed the column which has maximum number of missing values by selecting the module select columns in data set. Then we have used another module clean missing data, which will remove the row which has missing values. Now let's visualize our data. Right? So now let's visualize our data. So here in the clean data, select visualize. Now you will find here that there is no normalized column and there is no such columns and row where you will find any missing values, right? So this is all about the clean data. Now we will go to our next step on our next demo. I'm handing over this to Bhavesh. Thank you.
Let's look at the automated machine learning model selection. Now, let's say that you have a machine learning problem. So we have been taking the New York taxi data set. Maybe we have one more data set now, which is we want to predict the worth of a car, right? So we have all the characteristics of a car. We have a data set of car. and we want to see if we can predict the value of a car, and maybe it will be used by one of our clients, right? So here, and you can imagine any problem, let's say even the New York taxi data set problem, that given the data set, we look at the data, we do EDA, we do cleanup of the data. Then the next thing is that, okay, we need to create a model. What model should I create? What algorithm should I use? Should I use regression? Should I use a neural network? Should I use decision trees, random forest? There are hundreds of algorithms that you can potentially choose from. So which algorithm can I use, right? And so here, the Azure AutoML kind of helps you in that entire process. So you can imagine that the challenges the data scientist face is that what is the best machine learning model for my problem, and what are the hyperparameter values. So what is hyperparameter? Basically, for any model, you have varieties of parameters to choose from. For example, if you do decision trees, it can tell you what is the maximum depth of the tree do you want. If you're doing clustering, it will ask the number of clusters. If you are doing neural networks, it will ask the number of nodes and the hidden layers. So for the algorithms, it will ask a lot of input parameters from you, right? So how do I I need to give multiple parameters, and so that is called hyperparameters. And that is a very important part, because without the right hyperparameters, right, the right parameters, we will not be able to get a good model which will give us good accuracy or good precision or good recall, depending on or good low RMS model depending on the use case. Now, in the olden days, if I was a data scientist, I'll have to do a lot of work. Imagine that these are all the features that I have for in my data set. So we'll have to do feature selection, like how we have been doing it on day number 2 and day number 3, right? Then, depending on that, I will have a list of algorithms that I want to try out, right? So for example, I could have a gradient boost, I could have a regression, I could have a support vector machine. So I have varieties of algorithms that could solve this problem for me, right? And for each of these, for example, I have nearest neighbor, then I have to give how many number of a number of clusters that I want, right? And then if I have regression, then I have to give some other parameter, right? So for each and every algorithm, I'll have a bunch of parameters that I'll have to define as well, right? So you can very easily imagine that if you select some features from here, one algorithm from here, and some parameters from here, the permutation combination, you'll have hundreds of different combinations to try out from. So in the olden days, right, I will actually manually have a logbook. I will select some features, some algorithms, some parameters, run it. I will log, for example, if I'm trying to enhance it's a regression, so I'm trying to enhance for the lowest RMS, root mean square error, right? Then I'll note down, okay, what is the RMS for this combination? Then I'll change something, note down the RMS for that, and so forth. So it was a very tedious and time-consuming work. If you are a data scientist, you probably have in the olden days, you probably have interns or assistants who do this kind of work for you, where you define the parameters and give them the task of doing all this permutation and combination, running and observing the results like RMS, for example, because this is time-consuming, non-rewarding work. And luckily now we don't need to do this. Services like Azure ML Service have revolutionized this entire process by fully automating this. Let's see how we can automate this. So the technique of automating this is called AutoML, right? Essentially, this is very easy to understand. I have a data set with a set of features that I want to explore. I have some algorithms and optimization metrics that I want to choose from, and I put some constraints like I want this done in, let's say, 12 hours or 15 hours, or when my bill goes to so and so on Azure or so forth, right? And then I give all this to automated machine learning or AutoML. And what this does is that it tries different combinations of data sets, matrices, algorithms, right? And tries to produce the best model, and give me the best model with the best combination for me. So what it does is that, like I said, from data set and target metrics, is going to go ahead and create pipelines to execute. So for example, here we have set of features, some algorithms, some parameters, right? Some set of features, some algorithms, some parameters, and this is ran in parallel depending on where you are running it, right? And it measures, for example, for this this set of problem, I'm trying to optimize for accuracy, right? So it is noting the accuracy that is generating with these combinations, right? And it is noting that the fourth pipeline, right, it is giving me the highest accuracy of 95%. It will note that down, and at the end of the run, I'll be able to go and see that, okay, this set of features with this algorithm, with this parameters is the best accuracy that I've found so far, right? And if that's good enough, hey, I've solved the problem and I've saved a bunch of time by not having to do this manually. Instead of doing this manually, I'm using I'm throwing hardware at the problem, I'm giving it to AutoML and let it run this, hundreds, if not thousands of different combinations in parallel and give me the best combination of features, algorithms, and parameters, right? So then I have the top 3, for example, and then I can further optimize this, right? Then I can take the 3, further tweak something, further give it back to AutoML for further enhancement. So the entire process of finding the best model becomes much easier with AutoML. And you have a lot of algorithms to choose from. So you can see that just for classification or for regression, we were talking about the New York taxi dataset. This is a regression problem. And let's say you want to solve that problem, you want to predict the fare. Now you don't even know where to start. Guess what? You can select all these regression algorithms, right, and give it to AutoML with certain parameters and say, you know what? Run all these algorithms, give me the best one that works. You also have a lot of classification algorithm, and you also have a lot of time series forecasting. So all these algorithms that is listed over here comes out of the box for you to experiment in AutoML, right? You don't need to write a single line of code to have of the algorithm. You just execute AutoML and it uses this for you, right? So it's fantastic. So what's my process if I want to use AutoML? First is identify the ML problem, right? So in the New York taxi data set, we understand it's a regression problem. If I was doing something like face detection and trying to detect the emotions of the face, then that's a classification problem, right? I'm trying to figure out what is the stock price going to be, up or down within the next few days. That's a forecasting problem. So I need to find the problem. Now, depending on the problem, like we saw before, I have a bunch of algorithms to choose from. So if I have regression, I have all these regression algorithms to choose from. Then I define data source and format. So I have NumPy array, I have pandas data frame, I have varieties of different ways or different formats in which I can have my data. Then I configure compute target. So a compute target is, so as you can understand, if I'm going to have multiple algorithms, multiple types of parameters that I'm going to use, then I'll probably also need a lot of compute because I might be running hundreds of algorithms in parallel. So compute target is in essence where I'm running this model training algorithms, right? Where am I training my models at using those algorithms? So one, it can be local computer. If you have a really heavyweight, workstation with, I don't know, more than 100 GB of RAM and multiple cores, maybe you can do that, but definitely not recommended for standard machines, right? Because it's gonna really drain the battery. It's gonna use up all the CPU of your machine. Then you can also have Azure Machine Learning Compute. So this is a bunch of Azure VMs, which is kind of Azure ML will launch and configure for compute nodes, and it will run the algorithms on these machines. You have remote virtual machines as well that you can go and run from, and you also have Azure Databricks. So we actually went ahead and talked about Azure Databricks on day 1. So you can start an Azure Databricks cluster, especially if it's a Python-based workload and you're using the library called MLlib on Python to do your model training, then you can certainly use Azure Databricks, right? And you have also a few more options which are not listed over here in terms of your compute targets. So you define the problem, you select the algorithm, the data format, you give the compute target, and then you configure the AutoML parameters. For example, how many iterations I want to run this for. Now I can run for, I can just say, you know what, run for 50, 100 iterations and then stop. Or I can also give some other parameters for it to know when to stop. I can do hyperparameter settings. So I can go ahead and tell what parameters and what range of parameters to try. I can do pre-processing. This is the one where it will automatically clean up some of the data and do some feature selection and all that. Featureization of some of the attributes that I have, and what are the metrics that I want to aim for. So metrics is what, so because it is automatically trying to learn, we will have to tell them what it is trying to optimize for, right? So in this case, what it's trying to optimize for can be, let's say if it's regression, we know yesterday we talked about what are the regression metrics, right? You have RMS error, you have mean absolute error, things like that. So you can probably, if it's regression, you can choose one of those metrics to optimize. If you're doing classification, yesterday we talked about that you can choose, accuracy, precision, recall, F1 score, things like that, right? So you can choose those metrics. And then once you're done, you go and say run, and it automatically takes over and does everything for you. So here's the process that it follows, right? Here's my code for AutoML. I'm going to go ahead and write the code and submit the code to AutoML, right? So I define the source and the format, configure the compute target to run. So then I have to give what is my compute target, right? So for example, it could be, like we said, local machine, DSVM, it could be Databricks and so forth, right? So I have compute target. Then I define the machine learning objectives and constraint. So I say, hey, this is the set of algorithms I want to run, and I want to optimize for, let's say, RMS error. Yeah. Then launch the AutoML process. So you launch the AutoML process, and it generates a bunch of pipelines that it needs to execute. It creates a list of pipelines you want to execute, right? Then depending on the size of the compute, it will start executing those pipelines on that compute. Of the model that is created from this, it will go and do, it will analyze whatever metrics we have given. For example, we have given accuracy. It will notice accuracy for all these models, and the top end models, right, the top high quality models that looks promising are then stored. So at the end of this run, it could have tried thousands of models with different parameters. I only get a few high quality models that I can analyze, right? So this is and it may be that these high quality models are not that great itself, but at least it's a good starting point. Then I can take this set of data, right, again optimize, right, again try with some new parameters and run this AutoML. Again it gives me this. So it can be a process which you follow until you get the model with the right kind of accuracy that you want. So here an important step is pre-processing. This is basically data is pre-processed using standard and advanced pre-processing. So it does drop high cardinality or no variance features, right? So it figures out the features which are not useful. The high cardinality means something like, let's say in the New York taxi data set, we had the ID, the first column wasn't identified. It was unique value for every row. So that's high cardinality. And second can be no variance. So for example, let's say we have a column which is always 0 in the entire data set. Then that cannot be used for prediction, right? So it automatically removes that. It automatically imputes missing value. It generates additional features, right? For example, date time feature. So whatever we have done, right? Looking at the date time and extracting the day of the week and time, that is automatically done as well in this. So just imagine all the smartness that we have learned over the last few days, it already has those capabilities inbuilt. Now, you might say that if it is already there, why did we learn it? And I'll strongly mention that AutoML works best when you understand what's going on. If you use it as a black box where you just give the data and expect the best model to come out, it may work sometimes, but most of the time it is not going to work out. You have to understand it's a good starting point, and from there you'll have to further run it a few times with the right set of parameters and so forth to get the desired results. And if you understand what's going on, then that's really useful, right? So it generates additional features, transform and encode, right? There's some transformation required or encoding required, will do that. Word embedding, cluster distance, right? So all this is kind of done automatically. We looked at some of this as part of as part of our course. So it has a lot of inbuilt smartness for pre-processing the data as well. Then comes cross-validation. So we talked about this a little bit on day number 2. So essentially, it also does cross-validation. So imagine this is my data set, right? And traditionally I divide it, let's say 80% for creating the model and 20% for validation of the model. But a big issue here is that I can get unlucky and this data could be bad for creating model. So in that case, what I can do is I can use cross-validation. So instead of using a static list of 80%, it divides into several different folds, right? Where different, so for example, here the top 80% is used. The next one, it could be that the top from 20%, from 10% to 90% is used. So the top 10% and the bottom 10% is used for validation. Then maybe from 20% to 80, 100% is used, right? So it will basically take different combination of data for validation and testing. So what it does is that it takes away you can get unlucky in selecting the data for model creation. It takes away that effect, right? It will use all the data to create the model, not just the first 80% or random 80%. It will choose multiple kinds of data to create the model, and hopefully, it will choose the best one that works for the model. So with this, let's see a demo on automated machine learning, how you can run AutoML on Azure ML Studio.
Great. So thank you, Bhavish. Now in this demo, again, we'll predict the price of a car based on some different variables we have, like some make and technical specifications. But here we'll use the automated ML service to predict the price of a car. So let's get started. So basically what we have to do, first go to the ml.azure.com, or you can go to the Azure portal, machine learning service workspace, and there launch the studio. So after launching, you will be on this page, right? So here what we have to do, on the left corner, you will find this automated ML, which is on preview now. So click on this automated ML service. Right. Now then, these are some automated ML which I have run. So we'll create the new one. So let's create the new one. Right. After that, there are 3 steps to create the automated ML service. The first one is to select your data set and then configure the run. After that, we'll specify some task type and settings, right? So first, we'll select the data set. We'll create the data set first. So let's create the data set, and I'm using the file from my local. So I will click from local files. So I have downloaded the files, automobile raw data. So I will ping you the file on the chat window. So kindly have a look there and click on this. After that, give the name to your data set. Raw price data. Right. Let me copy this and paste it on the description. And then click next. After that, here you have to provide some details as in what data store you want. So select the default data store and then browse your file which is present on your local, right? So I'm browsing the file. So this is the file which I was talking about. I'm using this CSV file, which is automobile price data. And then it will get uploaded here. After that, just leave everything default, right? Just leave everything default. And let's wait for a few moments to upload the file. So let me go to the previous step. So here it is. So first I have given some basic info, as in the name I want to give to my data set, give some description, that's it. Then go next. Here you have to select the data store. So I have selected the default data store, right? And then this is my file which I have uploaded, the automobile price data row.csv file. So this file is on CSV format. Now click next. Right? So after uploading, you will find that this 100% it's got uploaded. Now here in the settings and preview, you will find that there are some rows and columns available. So these all are the rows and columns which you have given through the CSV file, right? So what we'll do, we'll leave everything default and click on the column headers, and here select all files have same headers, right? And then click next. So leave everything default, file format, delimiter, comma, encoding UTF-8, but put column headers, all files have same headers, and then click next. After that, here you will find that if you have remember on our previous demo, we have excluded the normalized losses column. Why? Because that particular column includes a number of missing values, correct? So here I am excluding the normalized losses column. Apart from that, when you check out here in the types, you will find like symboling is integer, and then make is a string. So you can check this out in your CSV file as well, that whether these all types are correct, but most probably everything's are correct. The only thing you have to change is the price column. So in the price column here, you have to select the integer. So by default, it is taking the string from the CSV file. So we have to put it integer there. So what I have done two things in this schema. First, I have excluded the normalized losses column, and then go down in the price, make the type integer. Correct? Now go next. Here I'll leave everything default and click create. Right? So you will find that now your data set is ready to use. Okay. Now this is my data set which I have just now created. So select this and then click on next. Now we are going to configure our run. So after selecting the data, we'll configure our run by giving some experiment name. So we'll create one new experiment. So here I'm creating automobile price prediction experiment. Right? And then here select the target column price. Why? Because we want to predict the price here. So we'll select the target column price. Yeah. Now here you can either select the existing compute or you can create the new one. So we'll create the new one first. So let me give some name to my compute instance. Right? And then here I'll leave virtual machine type CPU, virtual machine priority dedicated, and yeah, a minimum number of node. Let me increase to 1. And it is telling that to avoid charges when no jobs are running, set the minimum nodes to 0. And I am putting this to 4. Right? Okay. Okay, so make sure that you will find the green tick mark here. Compute cluster. Yeah, here it is. Now click create. So I have configured the compute cluster. So it will take some time, like 3 to 5 minutes to create one new compute cluster for you. Or if you want, if you already have any compute cluster, you can select that as well. Right? So let me select the existing one. So I'm selecting the existing cluster, which is the pipeline compute. Right? Okay, so it's got ready. Now I have selected the newly created compute cluster and then click next. So here again, let me give the experiment name, automobile price prediction experiment. You can give anything, whatever you want according to your convenience, and select the target column price and then select the compute cluster and then click next. After that, as you have remembered on our previous demo, we have selected the algorithm a linear regression. Why? Because we want to predict the numerical value. We have predicted the price column. So again, here we'll select the regression. After that, click on the view additional configuration settings and then select the primary metric. So I will select the primary metrics, normalized a root mean square. Right? And then here a tick mark this explain best model. After that, put the training job time 1 and then leave the metrics score a threshold none, and here in the validation select the train a validation split, as in it will split the data set into two parts, like for the training and the testing purpose. So I'm selecting the train validation split, and here I'm taking 30% of my data set for the validation purpose. Right? And then in the concurrency here, I will select 5. Yeah, now click on save. So basically this all, like here when you go up, this explain best model, it automatically shows the explainability on the best model which you have created, right? So we'll check out this after our automated ML get created. After that, we'll select the training job time for 1 hour, like so here in the exit criterion, basically here we are setting a criteria. So if a criteria is met, the training jobs is stopped, right? So I have specified 1 hour here, And then I've chosen the validation type, train validation split. I'm splitting my data set. After that, I have set the concurrency 5. So basically the maximum number of parallel iteration. So this 5 represents the maximum number of parallel iterations executed per iterations. Right? Now save and click finish. Okay. So basically this preparation times take some 10 to 15 minutes to prepare the environment. So basically once running it takes 2 to 3 minutes more for each iterations. So it will take some time. So let's check out the I have already created one. So let's check out that. So you will find that the status is a starting. So it's on running stage. So let's check out the already existing one. So I have created the one. Let me go back here. Right. And I will select this automobile. Yeah, here it is. So this is the one which I have already created. So after creation, you will find the status completed. Right. So you will find the status completed, and then you will find all the details, including when it got created, what compute target it is using. And then here you will find the best model summary. So basically voting assemble is the best model with having a less normalized root mean squared error, which is 0.05. Correct. Now, if you want to check more metrics here, you can check here as well. Right. And one also, like here you will find root mean squared error here is 2080.7. So if I go back to the one which I have created on the studio, so let's check out the visualization here also. So we'll check out the root mean squared. Yeah. So here the root mean squared error is 2456.98. Right, which is literally nearly equal to the one which automated ML has predicted. Correct. Now then close it. And you will find the task type which we have used in the regression one. Then here, if you go to the models, so in the models, if you have remember, we have explain the best model. So this is a voting assemble is our best model, and here you will find the view explanation. So these are some models which got created, and from this model the voting assemble has the best model. So let's check out the view explanation. So here you will find two features. One is the global feature and the another one is the summary features, right? So here when you check out the global features, so basically this features will tell you the top features which affect the price of the car, right? So let's suppose here I have selected the 5, right? I have selected the 5. So it will give you the 5 features according to, you can say, the decreasing order. So number 1, engine size has a more effect on the price in compared to the crab weight. Then there is a width, then length, right? So according to that, if we go like this, you find that this got decreased, right? So you find that a drive wheel and engine type has a less dependency on the price, right? So in the same way, if we check out the summary importance, here summary importance are visualized, or you can say a summary importance visualizations shows the distribution of individual importance value. So here, let me click any one point and then you will find the local feature importance. So basically by selecting an individual data point, it will show you the local features importance for the case to which the data points belongs, right? So in the same way, if we check out the metrics, here you can find out the metrics as well. So you can customize your chat, your table, right? If you want to add the medium absolute error, you can add. The same way, if you don't want, you can exclude from your chart and table, right? So here, now what we'll do, we'll deploy our model. So let's deploy our model. So to deploy your model, so basically here we'll deploy the best model, and our best model is the voting assemble. So let me click on deploy. And here give the name to your model, whatever you want, and then select Azure Container Instance and simply click deploy. That's it. So you find that the deployment had started successfully. So let's refresh it and go back to check the status. So here in the deploy status, you will find this as running. So basically it will take some time to deploy. So here you find that our voting assemble, which is the best model, got deployed. So it is taking some time to deploy. Okay, so the status of deploy status is succeeded. Now let's check out the endpoint. So I will click on this AS deploy endpoint. And here you will find that there are two endpoints, the REST endpoint and the Swagger URI. So basically in this endpoint, you have to send your data set and you will get the output of the best model. Why? Because this is the endpoint which will predict the best model for you. And when you send your data set, when you send your data to this particular endpoint, it will predict the price of an automobile. Correct? So this is all about the automated ML. I'm handing over this to Bhavesh. Thank you.
So now that we have created a model, the next step of the process is to deploy the model, right? So imagine that we have either a model ensemble or we have a single model that we really like, and then now we want to deploy the model. And that means that we want to deploy it and we want to ask for predictions from the model. In the New York taxi example we took, let's say we created a model which can predict the fare, and then maybe we have the model available somewhere where riders from their mobile phones can input the pickup location, drop-off location. All the data is sent back to this model and asked to make prediction, right? And then it sends back the user what the fare is going to be for their use case, right? So model deployment means that now the model is ready and we can ask the model for prediction. All right. So to make a model available for consumption, we can deploy. The target deployment environment supported are, where can we deploy the model? We can have a Docker image and deploy it anywhere where Docker is supported. We can deploy it on an Azure container instance. So as you know that a container instance is a machine which is basically you're not getting a VM, you're getting a container and you can run any container based workload on it. Then you have Azure Kubernetes service. So if you don't know about Kubernetes, it's a newest kind of way to run your containers. It's a very very upcoming and new way, very rapidly adopted way to run your applications. So our model will run as a Kubernetes service, and it is exposed as an endpoint where we can go ahead and consume it. Now, so all this kind of things, right? This is all in Azure. So imagine that this is my Azure data center, right? I'm using, let's say, US East region or India region. So if I use AKS, right, or if I use the Azure container instance, right, my model is deployed inside of Azure. Now imagine I have a remote factory. So let's say for my use case, I need to deploy, or the model needs to be consumed from the factory, and the factory is at a very remote location. So it might not be possible for the factory, it might not have good internet connection to go all the way, come back to AKS and then ask for prediction, right? It might need the prediction engine locally here, so that it doesn't need to go over the internet. And that can be done by Azure IoT Edge. So you have an Azure IoT Edge enabled device on the factory, and then you can directly push the model and deploy it over here. And now the factory can have a local environment from which it can consume the model. So really, really interesting and powerful way to consume your model in this case as well. Then you have field programmable gate array or FPGA. So for deployment, you need the following files. First is a score script file which tells Azure Machine Learning Service to call the model. So essentially this file, this core script file is important, and some samples are given to you. So you generate that. This will know how to call the model and what kind of parameters to pass to the model and so forth. And environment specific package dependencies to make sure that any dependencies that we have for the Azure, for the Kubernetes, for the Docker container, we mentioned that. And a configuration file request the required resources for the container, right? So basically, if you have that, it creates a deployable model for you, and then you can deploy it. The important certification questions. So question number 1, as a data science engineer for CloudDat, while making a credit card fraud detection model for a client, you realize that you are dealing with imbalance in data set, with fraud iterations being only 5% of the data set. Which of the below technique you may use to handle imbalance? The option we have here is undersampling the minority class. So like we discussed, you have data set, and let's say only 5% of the data set is of class fraud, the remaining 90% is non-fraud, right? So one is undersampling minority class, which means that you go ahead and instead of 95% data, you only use 5% of the data, and so decrease your data size to only have 5% of the majority and 5% of the minority. Second is SMORD, which is synthetic minority oversampling technique, right? Which is you increase this 5% synthetically by copying the data and make it 50-50. PCA, which is principal component analysis, and mice. So of course we've discussed about this that the right answer for this is SMORD. Alright, question number 2. As part of EDA, you need to identify skewness in the data set. Which of the below plot should you create? Right? So is it bar graph, histogram, box plot, or scatter plot? So here we had looked at varieties of the bar, different kind of graphs, right? Different kind of graphs and plots. If you remember, we had said that histogram, if you draw the histogram, then you can look at negative skew or positive skew of data set, right? So in this case, histogram B will be the right answer. Question number 3. While cleaning missing data in Azure Machine Learning Studio, which of the below method will conditionally model each variable with missing data before filling them up, right? So you have a data set, and let's say for some of the columns you have missing values in the data set. So and what you want is you want a method which will conditionally model each variable with missing data before filling them up. So let's say if you have a row and one of the attribute is missing, has missing value, right? It has to conditionally model and then fill. So the answer are replaced with mean. So as you know that this is probably not the right answer, because if you replace with mean, it is not conditionally modeling, right? It is just figuring the mean of the entire column, right, and filling the value with the mean. Similarly with mode, the same thing will happen, that you will fill a single value which is the mode of the entire column. And the custom substitution value will put whatever the value you select but won't be conditionally modeled. So the right answer here is C, which is mice, right? So with the mice method, we actually the mice actually looks at varieties of different columns and conditionally models it and then fills the missing value. Last question. As part of EDA, you need to identify the outlier in dataset. Which of the below plot should you create? Bar graph, histogram, box plot, or scatter plot? So here, as we discussed that, the scatter plot is the best way. The bar graph is the best way to find the outliers, because as we discussed that the outliers are represented as dots in the plot, and so it becomes very easy to find outliers when you plot a bar graph. So in this case, bar graph is the right answer. So you can expect similar question in certification, right? And
all right, so that's the end of module 2, right? Hope you enjoyed this module and you enjoyed all the demos shown as part of this module, right? So let's a quick revision of what we have learned today. First, we looked at the intro of the Azure AI ML platform. So here we looked at all the tools, all the systems available to us to do our data science on Azure. We looked at some of the low code and no code environments, like Azure Machine Learning Service. We had intro to that. We had Azure Machine Learning Visual Designer. We had Azure Machine Learning Studio, right? So we have a lot of those kind of features that we talked, where you have to write very little code. And even the folks who are not really good at coding can actually go ahead and perform the AI/ML experiments. Next, we also looked at the Azure Automated Machine Learning, Automated ML, right? And that allows you to kind of, as you saw in the demo, just drag and drop your way to create some really, really fantastic models without having to write a lot of code. So the summary of, if something I want you to get from module two rather, is that AI ML, right, the data science lifecycle, Microsoft Azure is the best platform to kind of do it end to end. There's some cool services. Even if you know code or you do not know code, in both the scenarios, you can do some really sophisticated AI ML techniques onto the Microsoft platform. So please go ahead and kind of, get your journey started on that. We'll be providing you with some go-dos later. So please finish that go-dos, which will solidify your learnings. Right. So now let's talk a little bit about the next module, which is module 3. Absolutely, I would say this is probably the most exciting module, right? Now that you have fundamentals in module 1, in module 2, you have seen how to create your AI/ML models and so forth as part of this machine learning service and studio. Module 3 is exciting. We will learn how to create bots, intelligent bots, using intelligent cognitive services. So here, basically, we'll talk about cognitive services. So, for example, in cognitive services, you don't need to do all this model development because models are already developed at the Microsoft end, right? So what you will see here is you will be able to just go ahead and call the APIs. Like, let's say you take a photograph, you call the APIs. The API will send back the data saying which in this photograph that there's a car or there's a truck or there is a human. The human is smiling. All this information you get right from the APIs. You don't have to write your own code, right? So that's really fantastic. And we'll have an intro to bot service and Q&A maker. So you can create some really sophisticated bots as part of this, and we'll see the demo. So if you join module 3, at the end of that module, you would have learned that how to create, and if you follow the steps, you'll have created a bot within just 10 to 15 minutes. So absolutely fantastic service, and really hope that you will take advantage of that and will join back for module number 3. If you haven't joined the module number 3 yet, go back to the same website for registration and register for module 3 as well. And one more important step for you is to claim your something called as MOC, Microsoft Official Curriculum, and your Azure Pass. So Microsoft Official Curriculum will help you. It's the standard book from Microsoft to help you study for the AI 900 certification. That's why it's called Microsoft Official Curriculum, right? So it's a wonderful book. There's a lot of information in there, and it's in digital format, so you can access it from anywhere, right? So to be able to do that, please go ahead and copy this URL. My team will also send that to you in the Q&A box, right? But please go ahead and copy and bookmark this. So just go here, ms.clouded.com/AI for students, right? All lowercase. So once you reach here, it will look something like this. You have a claim your MOC and Azure Pass button, right? Just click on this button, and it gives you the MOC as well as the Azure Pass. So these numbers are very important. Just copy them and keep them safe. Copy them and keep them safe. So MOC gives you the Microsoft Official Curriculum that you can use as, like I said, it redeems, when you redeem it, it gives you a book. And it's a nice book which you can use for reference and kind of reading. And, for future, if you have any questions, you can go back to that. Here's the redemption guide. So if you just click on this, so save this very carefully, go to the redemption guide, and you can see that here you have the user guide, FAQ, and everything. And so it tells you everything, how to register and log in, and how to add a book to your bookshelf, right? So there's something that you can quickly go ahead and do that. And you also have the Azure Pass. So you can get the Azure Pass, and you can click on the redemption guide as well. And you can go ahead and check what the redemption process is for getting your Azure Pass done. So the Azure Pass allows you to have $100 of Azure credits for $100 or $50, one of the two, for free without putting any credit card or anything like that, right? So this really helps you in doing all the labs that we are doing. So please finish these steps. Go over here to this URL and claim your Azure Pass and your Microsoft Official Curriculum both from this. All right, so these are your go-tos for module number 2. So please go ahead and take the URLs here. Maybe take a screenshot, take a photo from your mobile phone or something like that. So you have these links available to you. Bookmark them because these are very important. So there's a module 2 reference. There's the first link is for you to go ahead and reference the things that we have learned today. The second is the actual task. So it's very similar to what you have seen in the demos, but it's for you to go and perform it in your own environment. So the learnings that you have get solidified. And the last one talks about the AI 900 certification. So it's a really great certification, great for student community like yourself. It really, if you have that certification, you can put it on your resume, and it really embellishes your resume. It really makes your resume stand out compared to the other students out there when you're looking for jobs or internships or so forth. So highly encourage you to go and get that certification as well. It's kind of, there's a nice discounted rate for students as well. So, basically go to the website available and you can find more information over there. Great. So we will start with the Q&A session now. You can ask your questions via chat, right? So you have a chat box.